Welcome to Through Inquisitive Kids, and in this video we will be learning how to divide integrals. And so this is our course outline for Unit 7. You can see that we are already on our second to last lesson, and in the next lesson we will be learning about how to divide polynomials and monomials. Our learning goals for today is to understand and master how to divide integrals. And we're going to be able to apply what we learned to actual expressions, and we're going to be able to simplify them. So here's some review. Do you still remember the laws of exponents? A to the nth power times a to the nth power equals a to the n plus nth power. So we learned these four main laws of exponents. Of course there are more, and there is an entire other video based off of the laws of exponents. I will send you the link to that in the description below. And I want you to calculate the following four expressions in your head. See if you can do it without writing it down on paper. For the first problem, we have a to the 10th power. So we use a quotient of powers in this case. And over here, it is shown as the fourth law. A to the mth power divided by a to the nth power equals a to the m minus n power. For the second problem, we get y times z to the 5th power. In this case, we used the product of powers law. Since z squared and z cubed both have the same base, which is z, you can combine them and add the exponents together, but the base remains the same. So it's y times z to the 5th power. For number 3, we get c squared. Over here, again, we are using the quotient of powers. The base does not change. It's still negative c. And 4 minus 2 gives us 2. So it's negative c squared. But negative c squared is the same as c squared, because any negative number squared is positive. So negative c squared and c squared are the same thing. C squared is just more simplified. For the fourth problem, we have 2 times x to the 10th power. Again, we use the product of powers. So 4 plus 6 equals 10, so 10 becomes our exponent, and we're left with 2 times x to the 10th power. During a thunderstorm, you usually see the lightning flash before hearing the thunder. This is because the speed of light is faster than the speed of sound. If the speed of light is 3 times 10 to the 8th power meters per second, and the speed of sound is 300 meters per second, how many times faster is the speed of light than the speed of sound? So with today's learning, we can solve this problem. Can you simplify the following expressions? If so, how did you do it? Method 1. For the first problem, we have x to the 5th power y divided by x squared. We can think, what times x squared gives us x to the 5th power y? Since we are using the product of powers, we know that x cubed y times x squared gives us x to the 5th power y. And so our answer is x cubed y. You might be wondering, what are these 3 dots over here? So the 3 dots represent a mathematical language that you will be using when you prove something or when you are writing down your solution for a problem. This first 3 dots, it looks like an upside down triangle, is the same thing as because. So because we know that x squared times x cubed y equals x to the 5th power y, therefore, this is the second sign, therefore, x to the 5th power y divided by x squared equals x cubed y. For the second problem, we get 4n. Again, you think about what times 2m squared n gives us 8m squared n squared. And that would be 4n. Same method for the third problem. This one is a little bit more confusing. Over here, you might not see any coefficient in the first term, but there's actually a 1 over here. So what times 3 equals 1? We know that 1/3 times 3 equals 1. And then you think, what times a squared gives us a to the fourth power. Well, that would be a squared. And what times b will give us b squared? That would be b. And then we have to also put in a c. So our answer is 1/3 a squared bc. Of course, this type of method, you can't use it for solving harder problems. So we have a method 2. X to the fifth power y divided by x squared can be rewritten in fraction form as x to the fifth power y divided by x squared, which equals x cubed y. This can be rewritten as x to the fifth power over x squared times y. And then we just focus on the fraction part over here. So over here we are using the quotient of powers. It's one of the laws of exponents that we learned. X to the fifth power divided by x to the second power. Since they have the same base, the base does not change. And we subtract the exponents. 5 minus 2 equals 3. So we're left with x cubed times y. Same thing for the second problem. We rewrite them as fraction form. So 8m squared times n squared is over 2m squared n. And then we start canceling things out, and we start simplifying. These m squareds cancel each other out. The 8 and 2 cancel each other out, and we're left with a 4. And n squared is essentially n times n. And there's already one n below it. So we're left with the remaining n. So we are left with 4n. For the third problem, again, we rewrite it as fraction form. Again, there is a 1 hidden over here. So 1 over 3 is just 1/3. A to the fourth power divided by a squared equals a squared. B squared divided by b equals b. And c is actually going to be divided by a 1 over here. So we're left with c. So when we start canceling, notice how I canceled out the coefficients first, then the exponents with the like bases. Again, we divide the coefficients and the variables with the like bases separately, and then we put the results together. I want you to simplify these two expressions. So for the first problem, we have negative 3/5 x squared y cubed divided by 3x squared y. So again, we rewrite this. Negative 3/5 x squared y cubed is written over 3x squared y. We start breaking this up into smaller pieces. So negative 3/5 over 3 times x squared over x squared times y cubed over y. Now you can start simplifying. So for negative 3/5 over 3, it's the same thing as negative 1/5. X squared divided by x squared equals 1, so we don't have to care about that. And y cubed divided by y equals y squared. So our answer is negative 1/5 y squared. For the second problem, we first divide the coefficients. So 10 divided by 5. And then we divide the exponents with the like bases. So a, b, and c, we divide them separately. Using the quotient of powers, we get 2ab squared c. And then we have the second problem. This is not that hard. You can still look at the base as the same. So they're still like bases, except that their bases is an entire expression. Just look at it as a whole. So we are left with 2a plus b to the second power. And now what do we do? Well, we learned a formula called the perfect square formula, if you still remember. And the square difference formula and the perfect square formula will come up very, very often in harder math problems that you will come upon. The perfect square formula is a squared plus 2ab plus b squared. And that equals a plus b squared. And so when we use the perfect square formula, 4a squared plus 4ab plus b squared. I want you to simplify these two expressions. The solution for the first problem is 4xy. You divide the coefficients, 28 divided by 7 equals 4, x to the fourth power divided by x cubed equals x, y squared divided by y equals y. And for the second problem, we have negative 1/3 ab squared c. Simplify negative x to the fifth power y squared to the second power divided by negative xy squared. Use the power of a power property to simplify the first term. We get negative x to the 10th power times y to the 4th power. And then we divide and we get x to the 9th power times y squared. And here's the second problem. For the second problem, it's still the same thing. We put the coefficients together, then we put the exponents with the like bases together, and so we have negative 48 divided by 24 times negative 1, which gives us 2. And then a to the 6 minus 1 plus 5 power, which is a to the 10th power. Then b to the 5 minus 4 plus 2 power, which is b cubed. And then c. So our answer is 2a to the 10th power b cubed c. So you first simplify the exponents if there's any power of a power to consider, and then you divide and cancel out the top and bottom of the fraction. We are given that this equals this, and we have to find the values of a, m, and n. So can we do this problem now? During a thunderstorm, you usually see the lightning flash before hearing the thunder. This is because the speed of light is faster than the speed of sound. And so again, how many times faster the speed of light than the speed of sound if the speed of light is 3 times 10 to the 8th power meters per second and the speed of sound is 300 meters per second. So we rewrite this 300 in the scientific notation. We get 3 times 10 to the 8th power divided by 3 times 10 squared. The 3 and 3's cancel out, and the 10 to the 8th power divided by 10 to the second power equals 10 to the 6th power. And if you don't want to write it out in the scientific notation, you have a 1 with 1, 2, 3, 4, 5, 6, 0. And so you write your answer in a full sentence. The speed of light is 1 million times the speed of sound. Here's a harder problem to expand our thinking. We are given that 3 to the x power equals 5 and 3 to the y power equals 4. Find the value of 3 to the 2x minus y power. We are given that 3 to the x power equals 5 and 3 to the y power equals 4, and we're going to find the value of 3 to the 2x minus y power. We know that 3 to the 2x minus y power is the same as 3 to the 2x divided by 3 to the y power. We are using the quotient of powers in this case. So that is one of the laws of exponents that we learned in one of the earlier lessons. And we know that 3 to the 2x power is the same as 3 to the x power, and it's the same as 3 to the x power squared. So this is using the power of a power law that we also learned in lots of exponents lessons, and we already know that over here 3 to the y power tells us that it is 4. And 3 to the x power equals 5. So we're left with 5 squared divided by 4, which is the same thing as 25 over 4. And so our answer would be 25 over 4.